Today I'm going to discuss various rates and formulas to calculate rate in epidemiology and biostatistics. First of all, it's the crude rate. Crude rate is the actual measured rate for a whole population. Is the actual measured rate for a whole population. Crude rate help us to know actual burden of a health-related event, such as disease, birth, death. One of the good example of crude rate is crude death rate. So to write the formula for crude death rate is the numerator would be the total number of death divided by total population. So if the number of death is, for example, 50 and the population is, suppose, 5 million, then the rate will have lots of numbers after the decimal. So to avoid that, we can calculate the rate per 1,000 usually, or it could be like per 100,000 to get a nicer number. The specific rate is the actual measured rate for a subgroup of people specific rate is the actual measured rate for a subgroup of people or the population, subgroup of population, or it could be, rate of a specific disease or cause. If we distribute the population according to the age for age-specific subgroup, for example, 0 to 25.9, and then 26 to 45.9, or 20 40 45 46 to suppose 65.9 and 66 plus. This is how we can subdivide the people, okay? Subdivide the group of the population. Or we can subdivide based on a specific cause of disease. For example, the cause-specific death rate. Cause-specific death rate. To calculate that cause-specific death rate, okay. The cause-specific death rate formula would be death from a specific cause of disease cause. It could be diabetes mellitus, for example, breast cancer, etc., divided by total population. That's the cause-specific mortality rate. Or if we want to count like death, death among age group of 0 to 25, and then divided by total people, that would be age specific death. Standardized or age adjusted rate. Standardized or age adjusted rate is is where is adjusted to make group equal on some factors. The rate is adjusted to make usually the comparison groups equal on some factors. Example, age. We know that various population has different age distribution. So if we want to compare two population, like population A and B, we have to make sure the difference we found in the result is not due to a confounding factor, for example, difference in the age distribution. Suppose we have population A and population B. If we want to compare these two population, we have to standardize their the data, okay? Some factors by applying statistical method. In my next video, I'm going to discuss how to calculate, calculate age-adjusted rate, for example, death rate, by using the statistical method, which is direct and indirect. Case fatality rate. Case fatality rate is, the formula is deaths from a case, number of deaths from a cause, like cause means here disease, for example, that number of deaths from lung cancer, divided by number of persons with lung cancer. Number of persons with the disease or cause. Okay, that's the case fatality rate. So mortality rate from a case, that is from a cause, fatality from a cause. The last one is proportional mortality rate. Is the formula is deaths from cause divided by all death. Suppose a country has total number of death is 100 per year, or in any specific geographic area, total number of death is 100 per year. Out of this 100, 10 due to cancer, 20 due to diabetes mellitus, 50 due to, for example, natural cause, 20 due to accident, etc. So if we summarize this, all death, that would be 100, all death. And then proportion of cancer then would be, proportion of death due to cancer would be 10 divided by 100 into 100 maybe. So it would be 10% of death due to cancer. Just a rough estimate. That's all for today's discussion. Thank you for watching.